Greetings, Robotians. Welcome to the PCS Edventures Seminar Programming for Young Minds, Hands-On Education. My name is Carl Barcroft, and this is my colleague, Dalton Grover. Today we'll be discussing computer science and robotics engineering in the classroom. So let's get started. First off, let's talk about why computer science, programming, and robotics are so important to teach at a young age. The tech industry has the lowest unemployment rate of any industry, has the best pay, and is growing at an ever-increasing rate. Our society relies heavily on technology, and that is most likely not going to change anytime soon. Studying robotics not only increases students' technical skills, but also provides them with the ability to problem solve and critically think about issues, which will set them up for success in all that they do. Contrary to what a lot of people think, tech fields provide an environment rich in creativity, where the limits are only set by one's skills and imagination.
Thank you, Carl. Now we're going to talk about the solution that PCS Edventures has here. So we have curriculum designed to inspire. So with this growing need in schools and the marketplace, PCS has designed curriculum that will inspire students at a young age to pursue more STEAM education. And by STEAM, we obviously mean science, technology, engineering, arts, and math. PCS Edventures offers excellent curriculum that is coupled with advanced building materials to create a comprehensive curriculum focused on hands-on computer programming and robotics that can fit into any educational setting. In addition, PCS has over 25 years of experience in the education industry, giving us the background and the necessary tools to transform the way computer science is taught in classrooms around the country. Our curriculum is not traditional, nor is it basic, because we try to blend the most efficient tools of teaching methods to find what we call that sweet spot in education. So we'll talk a little bit more about our methodology and our curriculum principles later on. Right now, I'd like to introduce you to the Discover Robotics and Programming Kit that we're talking about today. So PCS Edventures has a series of curricula called the Discover series, and Discover Robotics and Programming is a piece of it. Discover Robotics and Programming is one of our newly updated kits, and it's designed for grades 6 through 8, focusing on the basics of robotics engineering and computer programming. The kit comes with everything you need to take your classroom to the next level of STEAM education. It comes with a programming software called Cortex. You can see right here. It comes with robotics and building, and it also comes with complete curriculum.
Yeah.
So we'll explain everything to you in detail, in each part of this revamped package. You want to start with the Cortex, Carl?
Definitely. So the Cortex, which is the software that I can kind of show you here. This software is extremely user-friendly. It looks and it feels great. It's gamified approach to programming and computer science, enhances the students' learning experience. The Cortex provides an easy-to-learn environment that supports all skill levels, from the novice to experienced programmers. It provides novices with programming concepts and structures that are present in all computer programming languages. That includes, like, if you can see here, we'll zoom in a little bit, and like up at the top here, we have a main function. Main function is common across all computer programming languages. The main exists to tell the computer what is the primary program that's going to be running from the program. It has an end feature, which is a good concept for students who are learning programming to realize that you have to end all of your code, whether that be with this end function or a semicolon or a bracket. The concepts are all embedded in this graphical user interface. And as the student advances and they become more familiar with the logic of programming languages, and they start making extremely complex programs with the Cortex, they can advance with the Cortex by looking at the code that they're building right here on the side, to see exactly the C language that's generated from the software for the brain. Once they decide they'd like to even move beyond that, they can take the code that they've developed already. They can export that into the Arduino IDE and use that to program their RIQ with more customized programs. The Cortex is probably one of the most advanced platforms that I know of. It allows you to do things that no other IDE lets you do. You can compile and run programs wirelessly, but not only that, you can do it from a tablet. You can do it from an iPad or an Android device, which is unheard of. It's nice. It's great for those small groups in classroom settings. While it does have the ability to communicate through USB, you're not required to be tethered at all with the software and with the brain. And speaking of the brain, I'm going to go over some of the components that are available in the Discover Robotics kit. The RIQ, this little guy right here, which stands for Robotics Intelligence Quotient, is specifically designed based on the Arduino platform for PCS, and is made to be used with the Cortex software as a computer science learning tool. The microcontroller that makes him possible is called the brain. This is the brain outside the case. As you can see, it's a nice standard microcontroller with several ports, and it comes wrapped in this case, pre-done in this case. The case is nice, has round edges, it's durable, and it's great for kids who are just starting out, who are young. Which most microcontrollers come more like this, which they're exposed, all their contacts are exposed, and it can be easy to short out any number of these connections. And also these pins are sharp. So for the younger kids, stuff like this is not really the best solution. The brain has a wonderful durable case that allows you to connect it with student engineering sets. And ours is specifically designed for Fisher Technics. The kit comes with its own set of Technics where you can build not only the RIQ, but also the
motor testing station.
Motor testing station, exactly, which is the introductory level to get them started with programming and robotics. That being said, while it does include Fisher Technics, and there's a lot that you can do, there's several pre-designed builds, as well as they can create things that the only limits of which are their own imagination and skill.
And we do have an additional website that will provide you with additional challenges, projects, builds, all that sort of thing. So
of course, yeah.
We've got that link right in the curriculum too. So once they finish all the projects in here, the learning doesn't end.
Exactly. And as far as that goes, the brain is not only designed for Fisher Technics, but you can use it with any student engineering set, whether that be Legos, Kinects, Vex, or anything out there, really. The brain is designed to be hooked up to pretty much anything and be able to control anything that you have in your classroom. While the brain is an important piece of the RIQ, no robot would be complete without its sensors that allows it to interact with its environment, the thing that makes it a robot. The Discover Robotic kit comes with several sensors to make the RIQ come alive. From the touch sensor for physical input, we have the LEDs for indicators, the sonic sensor, which is his eyes for depth perception. We have the infrared, which allows for to notice contrast. And then we have light sensors, for his photophobia.
Yeah, we like to call that build Scaredy Bot.
Yeah, that's a build included in the Discover Robotics kit. It's a great program to get them to learn how to interact with environments. The hardware and software allow the students to gain valuable skills with the help of the curriculum that is included in this kit. And Dalton right now is going to go over that curriculum.
All right, so the Discover Robotics and Programming includes everything a teacher needs to get started. The curriculum develops through 4 levels of projects and challenges, design projects, optional extensions, journaling opportunities, and much more. So the front of this will give you an overview of what to expect with the curriculum. It explains their philosophies and why we've chosen to set up the document the way that it is. From there, there's an introduction to the Cortex programming environment, as well as the PCS microcontroller, the brain, which Carl just told you about.
Yeah.
So this entire front section serves as an easy-to-follow user guide for all the robotics components and programming software that will be used. So as you can see, everything from the physical parts like the sensors to creating your first program in the Cortex are documented in this section. So we encourage educators to really familiarize themselves with this section of the manual. And then from there, we move on to the 4 levels of projects and challenges and whatnot. And there are some key aspects of this curriculum that we'd just like to highlight during this webinar. So one is that it creates a great model for teaching. 2, it provides a direct feedback and learning as a failure opportunity to empower its learners. 3, it supports Common Core, which is fabulous for all of you educators looking to supplement what you already have in your classroom. And finally, it helps break the entry barrier for both students and instructors to learn computer logic and to retain computer science skills. So first, I'll start off and tell you about how the Discover Robotics provides what we like to call an intelligent model for teaching. So by intelligent model, we simply mean that quite a bit of thought and research has gone into finding the best practices for information retention and student interest. On that note, we found a wonderful balance between a more unstructured student discovery process versus more of a direct instruction. And that has proven to be the most beneficial for student comprehension and retention for future uses. So this PCS structure has been developed over many years of educational expertise. And like I said, it begins with the directed projects, is followed by challenges and design projects. And this way you can start off with the concepts with the more directed projects. You can learn those and then move on to challenge yourself and then really get creative with the design projects. So with each step, they reinforce the concepts. Often in classrooms, there's a student-centered discovery process, which conflicts sometimes with just the more creative expression. And, so this structure also finds a balance between those two. If you take a look at the graphic on the screen, it perfectly describes the process I'm describing. Yes, it's the iterative discovery engineering process. So on either side of the spectrum, you can see that there's either random trial and error, where students just continue to try things without analyzing or testing before a new trial, or over analysis, where they expect their first trial to be right on the dot. So we found that middle spot, and it seems to be the most efficient form of learning. So in addition to our methodology, our curriculum is in line with modern engineering processes, such as the next generation science standards. And that's because in each activity, we include a reflective aspect to encourage thoughtful, reflective, effective iteration. And these skills are considered integral in engineering.
That's very true. And oftentimes, engineering and software development can be frustrating. The curriculum, however, is designed without formal assessment, so as to encourage the student to learn from their mistakes and to move forward. Fail early and fail often is a common motto in Silicon Valley. Having the students recognize their failure and employ critical thinking, problem solving to correct it, and this process makes for better engineers and scientists in the future. While this step can be difficult, it's not hindered by ambiguity like other heavily student-centered learning. The curriculum establishes clear objectives for the student so that they know exactly what they are aiming for, and the finish is always within reach.
Awesome. Now we want to talk about how this program specifically supports the Common Core standards. So with these new educational standards becoming the norm, we've striven to align our curriculum with such standards. Our products are designed to support educators in their classroom settings, despite how different they may be. And as I mentioned earlier about the next generation science standards, we closely align our curriculum with the Common Core. And one of the reasons being, it has become clear that many educators could benefit from support to instruct some of these new concepts emphasized by the standards. For example, as problem-based learning techniques are gaining momentum in the education realm, we believe this is part of an ideal environment to empower students. So Discover Robotics encourages students to create their own solutions to challenges, and we've found it best that when students generate novel and innovative solutions to problems on their own. So specifically, this program covers the language arts and the math requirements for grades 6 through 8. Often it is difficult for an educator to break the entry barrier into what may be uncharted territory, such as computer science.
Yep.
However, PCS's curriculum is designed to aid instructors and not overwhelm them. So Carl will explain a little bit more about that.
So, as many of you know, engineering and computer sciences can oftentimes seem daunting or even boring to many students. The Cortex and RIQ are designed to be visually captivating as well as user-friendly. The graphic-based programming software provides an inviting environment to explore programming and robotics. This system is not only helpful for students, but teachers as well. It's easy to use interface along with both instructor and student manuals enable teachers to quickly become familiar with software and be able to teach students in the classroom right away without months of prep work. It's just an amazing software suite and an amazing kit that I know you will find easy to use and easy to teach.
Exactly. Yeah. So overall, this is a great package for any classroom setting, and it is really a great way to start getting more steam into your classroom. So now I think we would like to open it up for some questions in the audience. Don't be shy, listeners.
Come on. Anything at all? No?
Well, if you do think of questions in the future, feel free to email us anytime. We'll answer any questions that may spring up later.
Definitely. And don't forget to visit the website, riq.adventureslab.com.
That will tell you more about the little robot. And if you want to learn more about other curriculum that we have available, just go to www.adventures.com. And, it'll give you a background of our company and any other questions that you may have. Right? Thank you for joining us.
Yes, definitely.
Have a great day, Robotians.